All right, welcome to The Explainer. Today, we're diving deep into the future of, well, discovery itself. We're talking about how AI researchers are making this leap from just being clever tools to becoming something like genuine thinkers. We're going to see how you go from an AI that just follows a loop to one that actually builds its own intuition. Let's get right into it.
So let's kick things off with this incredible vision from Andrej Karpathy. And look at the date, March 2026. He's painting a picture of a future where research isn't really done by us anymore, but by these swarms of autonomous AI agents. Now, I know it sounds like something straight out of sci-fi, but this vision, this is the spark that's igniting a revolution in how we discover things. It all starts with what you might call the first generation, the AI research assistant. And the prime example of this is Karpathy's own autoresearcher. I mean, think of it as the ultimate lab partner. An AI agent that can just tirelessly run experiments for you, 24/7, even while you sleep. A brilliant start for sure. And the way it works is this beautifully simple and really powerful loop. First, the AI suggests some code changes, then it trains a model for, say, a fixed 5-minute budget. After that, it checks the score, the result, and finally it decides, keep the change or throw it away. And then it just does it all over again. The secret sauce, of course, is that it's all guided by an LLM, which gives it a huge head start instead of just guessing randomly.
Okay, but here's the catch, and it's a big one. As smart as this loop is, there's a fundamental, kind of hidden problem. Just imagine this for a second. What if your most brilliant researcher woke up every single day with a case of total amnesia?
And that right there, that's the core issue. We can call it the memory glitch. It's the key difference between the current way of doing things and the next generation. It's the difference between just seeing a list of results versus actually understanding why those results happened in the first place. This slide just lays it out perfectly. On the one hand, you've got the current approach, Karpathy's auto-researcher. It sees a flat log file, a list of scores. All the learning it does happens in the LLM's short-term memory, its context window. And the second that session is over, poof, it's all gone. But the new approach, Auto-Researcher 2, is totally different. It's designed to figure out the why. It builds a permanent structural map of the entire research space. So here's the bottom line. The agent has no memory of the principles behind its successes. It's like a chef who knows that a specific cake recipe won a baking contest, but has no clue why. Was it the quality of the flour, the specific oven temperature? It only knows which recipe scored high, not the general insight that it could apply to other cakes tomorrow. So, how do you fix this amnesia problem? Well, that brings us to the next evolution, building a world model. Auto-Researcher 2 is built on a totally new philosophy. Instead of just reading a logbook, it grows its own internal brain. And at the very heart of this new brain is something called a generative model. Now, this isn't just about predicting which experiment will score well next. Now, it's about digging deeper. It's a model of the hidden causes, the underlying rules of the game that explain why some things work and others just don't. And the principle guiding this whole thing is a really powerful idea from neuroscience called active inference. You can think of it as a constant tug-of-war inside the agent's mind. It's always trying to balance the need to get a good result right now, that's the pragmatic value, with the drive to go explore and learn something new that might be useful later, that's the epistemic value. It's not just a score chaser, it's genuinely trying to figure things out. Okay, so how does this new mind actually work in practice? Well, the system is cleverly designed with two distinct jobs, two personalities working together. You can think of them as the scientist and the librarian. And this table really shows how they split the work. The scientist, that's our generative model, it handles the big picture questions, like, is this technique, rope, generally a good idea? It understands the abstract concepts. But the librarian, that's the memory system, it handles the nitty-gritty details. If you ask, hey, did I already try this exact setup before? The scientist has no idea, but the librarian, it knows. It prevents you from running the same experiment twice. The scientist creates theories, the librarian remembers the facts. This is where it gets really, really cool. If you have this system that can learn and remember, a fascinating question comes up. How does an AI decide what's actually interesting enough to investigate next? I mean, how do you engineer curiosity? And the answer isn't just about finding things that are random or novel. No, the signal for what's truly interesting is way more sophisticated than that. The system uses a concept inspired by this idea called learntropy. And the core idea is actually pretty intuitive. The best learning happens right at the edge of your knowledge. Think about learning a new language. The most useful new word isn't a random sound you've never heard. It's a word you don't know yet, but you can understand its context and connect it to what you do know. It's that sweet spot, surprising but also makes sensible.
So the system literally looks for specific signals, these aha moments. It's asking itself, how much did that result just change my entire worldview? Did it completely contradict a theory I held? Did it force me to totally reorganize my mental map of this problem? And hey, how widely useful could this new insight be? It's basically a detector for genuine scientific breakthroughs. So where does this all leave us? What does this all add up to? Well, it's a fundamental shift, a smarter path to discovery. It's about moving from a simple, repetitive loop to a sophisticated system that actually gets smarter over time. It really boils down to these 4 massive advantages that AutoResearcher 2 has. You've got that generative model that sees the hidden patterns. You've got the smart policy that knows when to learn and when to go for the win. You've got that appraisal module that can actually spot what's interesting, and of course, that persistent memory that stops the amnesia. It's the difference between just running tests and developing real intuition. And what I absolutely love about this whole project is that it's not just a bunch of cool ideas. They're holding themselves accountable with real science. They've laid out clear, tough criteria for what success even looks like. For example, they're asking, does the memory system actually make a difference? If it's not at least 15% better than the version without it, then it's a failure. There's no moving the goalposts here. Which leaves us with a truly profound thought to chew on. We are right now watching the transition from AI agents that simply follow instructions to agents that can build their own understanding, that can develop their own research intuition. It's opening up a frontier we've only ever dreamed of. So the real question isn't just what we can discover anymore, it's what will an AI with genuine curiosity choose to discover next?